In this chapter, we're going to start doing actual calculations with our data sets. We're going to go back to the concepts of center, variation, and distribution from the last chapter, talk about those in a little bit more detail, and talk about the calculations we can do to learn more about those ideas. The formulas that we talk about in this chapter use some different notation, so here's a slide with some of the notation that you need to be familiar with. First is the sigma symbol. A capital sigma before something says to add all of those values together. An X will just be some piece of data from your data list. And then N stands for how many are in a group. So a lowercase n is talking about a sample, and a capital N is talking about the whole population. In this first section, we're going to focus on measures of center, sort of your average value for a data set. And it turns out that there are actually several different kinds of center that you can talk about, and so we'll go through all of these: mean, median, mode, and mid-range. First, we'll start with mean. There are actually several types of means that can be calculated. The one that you're probably most familiar with already is the arithmetic mean. We often just call this the mean. And this is the average that you've probably calculated before by adding up all of the values and dividing by how many there are. The symbol that we use for this when we're talking about a mean depends on whether you're talking about the sample or the population, and you'll notice this throughout the chapter that there's different notation for samples and populations. If it's a sample mean, we use the X bar symbol, and if it's a population mean, we use the lowercase Greek letter mu, so it looks like a U with kind of a long tail on the left. When we're doing calculations in this class, there are some pretty particular rounding rules that we'll need to follow when our answers don't come out even. In statistics, the number of decimal places that you use signals to the reader a degree of precision. It tells them how many decimal places out you can be sure of your answer. And so it will seem pretty tedious as we go through trying to keep track of how far out you should be rounding, but it's actually kind of important. And so for our measures of center, mean, median, and mid-range, we're always going to round to one more decimal place than you have in the original data set. And I'll explain that more as we go through. What you will need to remember is that if a number comes out even, you may need to add zeros on the end to get the right number of decimal places. So even when you're talking about people or cars or things that can't be halves, you will probably still have decimal places in your answer. A second kind of mean that we often use is a trimmed mean, which takes out high and low values in the data set, and we use this to sort of counteract extreme values on either end to make it more representative of the values in the middle. Sometimes that is not desirable, but often it is, so we're going to look at how to calculate a trimmed mean. So let's say we have the following set of test scores and we want to calculate a 5% trimmed mean. So the first thing you need to do to calculate a trimmed mean is count how many values are in your data set. So in this case we're dealing with 19 test scores. And then once you figure that out, you need to find the percentage of that number. So the percentage will be given to you when you're asked to do a trimmed mean. In this case, we've been asked to do 5%. So I need to know what 5% of those 19 scores is. So I go ahead and find 5% of 19, which comes out to 0.95. Now this is how many scores I'm going to get rid of out of the list, so I need to round that off to a whole number. So if it's 0.5 or higher, go ahead and round up to 1. If it were lower, then you'd round down. And then whatever number you get, in this case the 1, that tells you how many to take off the top and how many to take off the bottom. So you'll do both. So 1 off the top, 1 off the bottom. That's going to leave me 17 scores, and I've got the new list written there. Then you'll find the average of the 17 scores that are left. So you'll add all of those up and divide by 17. And then because all of the numbers in our list were whole numbers with 0 decimal places, our rounding rule says that we need to go one place farther than that. So we're going to round to 1 decimal place. So in this case, that's going to give us 83.5. Next, we're going to talk about a weighted mean, which is when some categories count for more than other categories, which is what many professors use to calculate grades. So let's say you're taking a class and this is what your syllabus says. Homework's worth 10%, quizzes are worth 20%, exams are worth 50, and the final's worth 20. So with this kind of grading scheme, you can't just add up all your points and then add up all the points possible and divide, because this is saying that each category is worth a certain percentage of your grade, which means you actually have to work with the averages from each category and weight them properly. So we're going to look through an example on how to do this. Let's say you're getting perfect scores on all your homework and you have 130 out of 130 points. And then let's say that out of 20 points each, those are your quiz scores, your exams are out of 100, and then final exam score as well. And so we're going to look at how to find the weighted mean on this grade. So the first thing you need to do is find the average within each category. So for homework, you've got 130 out of 130, that's 100%. For the quizzes, we've got 6 quizzes worth 20 points apiece. The quiz scores add up to 108 out of 120 total possible, so that's 90%. And then 3 exams for 100 points each, so that's out of 300. Add those up and you've got a 75% exam average. And then final exam 104 out of 150, so 69.3 on the final exam. This is actually a fairly typical grade breakdown where people do very well on homework and quizzes, struggle a little bit more on the exams, and then have a little bit of trouble on the final. Now that you have all the category averages, you need to weight those and put them together for the final average score. So the homework average was 100%. We're going to multiply that times 10% because that's what homework was worth. And then the quizzes are worth 20%. There was a 90% quiz average, so I'm going to multiply that times 20%. Exams were worth 50. There was a 75% exam average times 50 because it's worth 50%, and then the final was worth 20%, so 69.3 on the final times 20%. And you can see there that I've multiplied those together and then added them all up. That's in the top of the fraction. And then I'm going to divide by the total weight possible. So we had 10% for homework, 20% for quizzes, 50% for exams, and 20% for the final. That's 100% total. So I'm going to add all that up and divide by 100. Again, since we've been dealing with whole numbers for our grades, the mean needs to go out to 1 decimal place. So that comes out to 79.4% for the final weighted mean or final grade. A related idea is finding the mean of a frequency distribution. So frequency distribution, like we worked with in Chapter 2, where you have the 2 columns, the categories, and then how many are in each category. Now the difficulty with those is how do you find a mean if you only have the frequency distribution? So let's take a look at that. So let's say we have a frequency distribution for the ages in some sort of club, and you only have the categories and how many people fall into each category. What you don't know is what the actual ages are. So we know that 4 people are between 20 and 29, but I don't know, are they 20, are they 22, are they 27? It's hard to find a mean age when you don't have the ages to add together. So the way we handle that is we just say, okay, I'm not going to be able to find an exact average, but I'm going to just assume that everyone in each category is right in the middle of the category. So here you can see I've gone ahead and found the midpoint for each of those classes. So from 20 to 29, the midpoint would be 24.5. That's just the average, 20 plus 29 divided by 2. And I've gone through all the classes and found the midpoints for each. So I'm going to assume that all 4 of the people in the 20 to 29 category are 24 and a half years old, and so on. And then the other thing that I've done is totaled up the frequencies to find out that we're talking about 28 people here. So if I'm assuming that all 4 people in the first category are 24.5 years old, then I'm going to go ahead and multiply 24.5 times 4 people to get 98. So what I'm doing is I'm trying to add up all the ages so that I can divide by how many there are. So 4 people are 24.5, and then 8 people are 34.5, and so on. And then once I get each of those sorted out, I go ahead and add all of that together to get a total of 1156. So that's like adding up all of the ages. Then we had figured out before that based on the frequencies we were talking about 28 people. Now I've got the 1156 from adding up all the ages, so I can go ahead and divide that by 28 people. Now ages are whole numbers, and so we're going to go ahead and round to 1 decimal place. That'll be 41.3 years old.